Hello everyone, welcome back to Math Verse by Vishal. So in the last videos, I discussed about the top 10 PYQs from the chapter quadratic equations, right? So now in this video, I bring the top 10 PYQs which you must know before going to your JEE mains second session from the topic complex numbers. So let us take the first question for this video. For a non-zero complex number z, let argument of z denotes the principal argument of z with argument of z lies in between minus pi to close to pi, and let omega be the cube root of unity for which argument of omega lies in between 0 to pi, and also a value of alpha is given, that is argument of sigma n is equals to 1 to 2025 minus omega to the power of n. Now in this case we have to find out the value of 3 alpha divided by. So let's try to analyze what is the given question. First, they said that the complex number z is non-zero. So let's put all the conditions whatever are given. So z is not is equals to 0. And moreover, they said that the argument of z should be chosen in between open minus pi to close to pi, which is obviously the principal interval of any complex number. And the omega is given as the cube root of unity. And with omega, argument lies in between 0 to pi. Okay, so which means you must take your omega as what? Minus 1 plus I root 3 divided by 2. Or also, if you want, you can write it in terms of exponential form. That is e to the power of pi 2 pi by 3. Okay, so this is your omega. Now, alpha is given. So, first let us write down that sigma part, right? That is, if I take this sigma n is equals to 1 to 2025 minus omega to the power of n. So if you expand this, what you are going to get obviously minus omega plus omega square minus omega cube and then so on up to minus omega to the power of 2025. So very clearly, this is forming a geometric progression of 2025 terms where the first term is minus omega and the common ratio is also minus omega here. Okay. And we know how to find out the sum of n terms of a geometric progression. So let us do that. So a into that is minus omega multiplied by common ratio is minus omega to the power of number of terms is 2025 and minus 1 whole divided by minus omega minus 1 a into r power n minus 1 divided by r minus 1. Now let's try to simplify. First, if I cancel out the minus sign in both numerator and denominator, the remaining part will be omega by omega plus 1 multiplied by, now this will be minus of omega to the power of 2025. But we know how to reduce this higher powers of omega, right? We just try to divide the power 2025 by 3. Whatever is the remainder that we have to write down in power. So if you divide this 2025, I'm sorry, if you divide this 2025 by 3, what is the remainder? Check it. So it is 3 6 18. So next 3 7 is 21 and then 3 5 is 15. So clearly 2025 is a multiple of 3. So which will give you minus 1 and minus 1. And finally what you get is minus 2 omega divided by omega plus 1. And what is one more property that we know about cube roots of unity? It will be 1 plus omega square is equals to 0. So in the place of 1 plus omega, now you can replace minus omega square. So finally what we get is minus 2 omega divided by minus omega square. So now which means the remaining part will be 2 divided by omega. Okay. But once again, 1 by omega can be written as omega square. So 2 by omega is nothing but omega square here. Okay. So once again, try to go through that, whatever we have discussed. So this is the value of sigma n is equals to 1, yeah, 1 to 2025 minus omega to the power of n, which is 2 omega square. But alpha here in the question is given as argument of this value. So let's try to put that. Alpha is equals to argument of 2 omega square. Now we know the property here. I can write this as argument of 2 plus argument of omega square. But argument of 2 will be is equals to 0, right? Because it's a 2 is a positive real number. So argument of any positive real number will be 0. So which means the only remaining part is argument of omega square. Now we know what is omega. So just now I've written that omega is nothing but e to the power of I 2 pi by 3. And obviously you get omega square as e to the power of I 4 pi by 3 if you square on both sides. But here we have to make sure the argument should be taken in the interval minus pi to pi, right? So that is why I will rewrite this as e to the power of minus I 2 pi by 3, because we know that that 4 pi by 3 angle will be obviously same as minus 2 pi by 3, right? So clearly omega square value is e to the power of minus I into 2 pi by 3. So by looking at that omega square value, what is the argument of this complex number omega square, which is clearly minus 2 pi by 3, right? So we get the value of alpha. Now let's look at what is the required part here, that is 3 alpha divided by pi. So 3 alpha divided by pi is equals to 3 by pi times of alpha value is minus 2 pi by 3. So you can cancel out and the remaining value will be is equals to minus 2. Okay. So the question is simple. It is involving a concept of geometric progressions and also cube roots of unity. Okay. And don't make this mistake here that even if you are writing omega square is equals to e power I 4 pi by 3, there's no problem. But in the question, it's mentioned that argument of any complex number should be taken in the principal interval minus pi to pi. That is why we are choosing it as minus 2 pi by 3. Okay. Let's take the second question. Now, this is a question from JEE Advanced 2024. Now, given that f of x is equal to x power 4 plus ax cube plus bx square plus c be a polynomial with real coefficient. So be very careful. They said that it is having real coefficient. So which means a, b, c, everything belongs to real numbers here. A comma b comma c belongs to capital R. And also given that f of 1 is equals to minus 9. So let's put the condition. If f of 1 is equals to minus 9 here, which will be 1 plus a plus b plus c is equals to minus 9. This implies a plus b plus c is equals to minus 10. So we have one condition in terms of a comma b comma c. Let's take it as equation number 1. Now let's continue the question here. Is given that I root 3 is a root of the another polynomial equation, that is 4x cube plus 3ax square plus 2bx is equals to 0. But I can take x common here, right? So if I take x common here, the remaining part will be 4x square plus 3ax plus 2b is equals to 0. So clearly you have two factors here. One case will be x is equals to 0. Other case will be 4x square plus 3ax plus 2b is equals to 0. Okay. Now clearly they said that I root 3 is one of the root of this equation here. But if you look at this polynomial equation 4x squared plus 3ax plus 2b is equals to 0. All the coefficients 4, 3a and 2b are real numbers here. Now we know the property very well. If the coefficients of a polynomial are real numbers, then the complex roots will be occurring in conjugate ways, right? So that is the reason they have given you ABC belongs to Kepler. So we conclude from here that I root 3 is a root already given to us in the question. But we know that minus I root 3, the conjugate pair, also is a root of this equation. So let's apply sum of the roots and product of the roots of this one. So sum of the roots will be I root 3 minus I root 3 is equals to minus 3a divided by 4. And we get a is equals to 0. Similarly, if you apply product of roots, that is I root 3 multiplied by minus I root 3 is equals to c by a, that is 2b divided by 4. And we can find out the value, right? Right hand side it is 2b by 4 and left hand side it is 3. So finally, b will be is equals to 6. Okay. And you can take these values of a and b from here and put it in equation number 1. From there you get the value of c. So let's do that. So which will be 0 plus 6 plus c is equals to minus 10, and hence we get c is equals to minus 16. So we have found out all the three values a comma b comma c. So as I told, the condition ABC belongs to capital is given for this purpose only, that that equation, polynomial equation has one root as I root 3. So it will have a conjugate pair minus I root 3 just because ABC, that the values A and B are real numbers here. Okay. Now let's go back to the question. Given that alpha 1, alpha 2, alpha 3, alpha 4 are the roots of the equation, f of x is equals to 0. Now, since we know the values of a, comma b, comma c, let's construct this f of x polynomial, which will be x power 4. A value is 0, so b value is 6, so this will be plus 6x square, and c value is minus 16. So we get the simple polynomial f of x as x power 4 plus 6x square minus 16. So we need to find out the roots of this polynomial, right? So make it equals to 0. And it's clearly factorizable if you take x square is equals to t here. So I can write this as directly x square plus 8 multiplied by x square minus 2 is equals to 0. Okay. So which means you get x square is equals to minus 8 as one of the root, and x square is equals to 2 as other solution, right? So from here, we can say that x will be is equals to plus or minus square root of 8i, okay? Because you have a negative number, right? So you have to include I there. And if x square is equals to 2, we know that x is equals to plus or minus root 2. Now, given that alpha 1, alpha 2, alpha 3, alpha 4 are the roots of this polynomial, so you can take it like this directly. Alpha 1 is equals to root 8i, alpha 2 is equals to minus square root I, and alpha 3 is equals to square root of 2, and alpha 4 is equals to minus square root of 2. And in the end, what you're supposed to find out that modulus of alpha 1 square plus modulus of alpha 2 square plus modulus of alpha 3 square plus modulus of alpha 4 square. Okay. Now I think you can do the remaining calculation part, right? So the modulus value of alpha 1 is square root of 8. Since you are squaring it, it will be 8 plus again alpha 2 also has the same magnitude, right? Magnitude. And alpha 3 and alpha 4 have the magnitudes as root 2 and root 2. So since you square it, you get it as 2 plus 2. So finally, it is going to be 20. Okay? So the question is not difficult here. The only idea you have to get is the concept conjugate pairs of a polynomial, conjugate roots of a polynomial. Okay? Now let us take the third question for this video. Let z bar denotes the complex conjugate of a complex number z, and z is a non-zero complex number for which both real and imaginary parts of the complex number bar whole square plus 1 by z square are integers. Okay, so whatever this complex number is given, z bar whole square plus 1 by z square. Now, if you express in terms of real part plus I into imaginary part, now they said that the real and imaginary parts must be both integers here. Okay, and finally, we have to find out which of the following is our possible values of mod z. Okay, so obviously you have to find out value of mod z in this question. First, what we'll do is, let me take this complex number here, z bar whole square plus 1 by z square is equals to some m plus I into n. Okay, because it's also that is also a complex number, right? So I'm taking it as m plus I n, but it is given that these m comma n must be belonging to integers. That's what they said. The real and imaginary parts are integers. Okay. Now I'm going to do a small simplification here. In the term 1 by z square, okay, in the second term 1 by z square, I will try to multiply and divide z bar whole square. Okay, you can look at the calculation that I'm doing here on the right. So 1 by z square, if I multiply and divide by z bar whole square, it will be z bar whole square divided by, now the denominator is what, z square into z bar whole square, that can be written as z into z bar whole square. But what is z into z bar mod z whole square? So which makes the denominator here as mod z whole to the power of 4. Okay. So let us take that and substitute it back here so that the equation here reduces to z bar whole square plus z bar whole square divided by mod z to the power of 4 is equals to m plus in. Okay. Now we are going to do the simplification process that here I can take this z bar whole square common, right? So if I take common, it will be z bar whole square multiplied by 1 plus 1 divided by mod z whole to the power of 4 is equals to m plus in. Okay. Now what I'm going to do is I'm going to equate the real and imaginary parts on both sides of the equation. But for that, I need the expansion of what? Z bar whole square. But we know how to expand this Z bar whole square, right? So Z bar is nothing but x minus iy and whole square is also there. So if you square that, you'll be getting x square minus y square minus 2 into ixy. Okay. But anyhow, the main advantage is this second bracket here, 1 plus 1 by mod z whole power 4 is a real number, right? Because mod z is a real number, right? So if I try to equate the real parts on both sides of the equation, I get one equation that m is equals to the left hand side, the real part is what? X square minus y square, and you are multiplying that with 1 plus 1 divided by mod z whole to the power of 4. Similarly, if we equate the imaginary parts on both sides of the equation, right hand side it is obviously n, and left hand side, if you look at that, imaginary part is minus 2xy, and that you are multiplying with what? 1 plus 1 divided by mod z whole power 4. Now you have both values of m comma n here. Okay, now the idea for this question is just you have to try to square and add both these equations, that is both the values of m and also n. Okay, so let's do that. Let's square and add. M square plus n square is equals to, first of all, this 1 plus 1 by mod z to the power of 4 is common in both of them, even if you square and add. So I will take that part common first of all. So 1 plus 1 divided by mod z to the power of 4 whole square common. And then the remaining part, which is x square minus y square whole square plus minus 2xy whole square. Okay, but if we observe carefully, this one x square minus y square whole square plus minus 2xy whole square. If you expand, what you are going to get there? X power 4 plus y power 4 and minus 2x square y square plus 4x square y square. So which reduces to, I'm going to write it here, x power 4 plus y power 4 plus 4x square into y square. So which is clearly a perfect square, right? So let me write down. This is equals to 1 plus 1 divided by mod z to the power of 4 whole square multiplied by, now the remaining part is directly a perfect square, that is x square plus y square whole square. Okay, and this is the value of what? M square is n square. Okay, but there is one more observation which is to be made here, that this x square plus y square, this x square plus y square is nothing but what? It's the square of modulus value of z, right? So that is mod z whole square, and again whole square is there. So if you try to simplify, you get it as, and moreover, let's expand this one also simultaneously. This will be 1 plus 1 by mod z to the power of 4 whole square multiplied by, this will be mod z whole to the power of 4. Okay. So just expand completely here. That is, you will expand the first bracket, that is 1 plus 1 divided by mod z whole to the power of 8 plus 2 by mod z whole to the power of 4 and whole multiplied by mod z to the power of 4. So if you do that, this is what you're going to get. Okay. Mod z to the power of 4 plus 1 by mod z to the power of 4 plus again that will be cancelled out, right? Only 2 will be remaining, and finally we get the result m square plus n square is equals to mod z whole to the power of 4 plus 1 divided by mod z whole to the power of 4 plus 2. Okay. So this is how the equation reduces to. Okay. So it's a lengthy question. Definitely it's not an easy question because a lot of calculations are involved here. Once again, you can try to go through it. So at last, what we are reducing it to is m square plus n square is equals to mod z whole power 4 plus 1 by mod z whole power 4 plus 2. Okay. Now there is a problem with this because you cannot solve it directly. It's difficult because we have three unknowns in the equation. Mod z is not known and m comma n are also not known to us. And in the last video also I told you, right? Whenever we have number of variables more than number of equations, the only thing is we can substitute and check. Okay, now let's keep it aside. Let me take it as some equation number 1, which the value of mod z has to satisfy. Now you have to verify option by option. Now let's take the first option here. In the first option, mod z value is given as 43 plus 3 into square root of 205 divided by 2 whole to the power of 1 by 4. Okay. So that is because if you look at that, the options, each and every option there is representing mod z value, right? So let me take the option 1 first. Okay. So let's take option 1, option A, given that mod z value is what? Let me look at that. 43 plus 3 into square root of 203, I'm sorry, 205 divided by 2. 205 divided by 2 whole to the power of 1 by 4. Okay. Now from here, if I do whole to the power of 4 on both sides, I will get this as mod z whole power 4 is equals to, this is 43 plus 3 into square root of 205 whole divided by 2. Okay. Now you have to take this value of mod z whole to the power of 4 and substitute back in the equation number 1. So let us do that, from which you'll be getting m square plus n square is equals to. So directly we have the value of what? Mod z whole to the power of 4, which is nothing but 43 plus 2 into square root of 5 divided by 2, plus we have reciprocal 1 by mod z whole power 4, so which will be 2 divided by 43 plus 2 into, I think it's 3 into, right? I'm sorry, this is 3 into. Hmm. So plus 2 divided by 43 plus 3 into root square root of 205 and plus 2. Okay. Now you can rationalize the second term obviously here. So when you try to rationalize this second term and simplify, at last what you are going to get is, I'm leaving the calculation part to you so that you can do it later. So you get m square plus n square is equals to 45. A simple equation, m square plus n square is equals to 45 when you solve the option A here. Okay. Now here in the question, we have to make sure the values of m and n are integers. So we have to check whether this equation m square plus n square is equals to 45 will be satisfied by any set of values of m comma n which belongs to integers. Okay. Now you have to verify. So clearly this is 45. I can write this 45 as what? 36 plus 9. So which means I can take one possibility is I can take m is equals to uh, plus or minus 6 and n is equals to plus or minus 3. So if you do that, you get m square as 36, n square as 9, 36 plus 45, which is equals to 45. Hence, there is a possible combination of m comma n, which are plus or minus 6 comma plus or minus 3. You can take it in the reverse way also, no problem, but we just need to make sure there is a possibility of m comma n satisfying m square plus n square is equals to 45. Hence, first option is possible. Okay, because in the question also, if you look at that, they are asking possible values, which means there are multiple answers for this question. Okay, so this is a process. So here in this video, I'm only doing option A, that is verification of option A. Now it's your turn to check whether option B, D, and C will satisfy or not. Okay, so this is like a work for you. You can try this question. Okay, and it's a multi-correct question from JEE Advanced 2022. To try it. Let's take the next question. This is a question from JEE Advanced 2019. It's a pure geometrical application question from the chapter complex numbers. Now let's read the question. Let S be the set of all complex numbers satisfying modulus of z minus 2 plus I greater than or equals to square root 5. So let's analyze this first inequality, then we'll go to the next part. Modulus of z minus 2 plus I greater than or equals to square root of 5. So it is similar to the inequality that we already know, that modulus of z minus z1 greater than or equals to r. And this is representing the region on or outside the circle with center as z1 and radius is equals to r. Okay, so we know this inequality represents on or outside the circle whose center is Z1 and radius is equals to R in the complex plane. Okay, so by using that logic, if I try to rewrite this given inequality as modulus of Z minus of, if I take minus common, I'll get 2 minus I, which is greater than or equals to square root 5. So we have the center Z1 is equals to 2 minus I, which is also same as the coordinates 2 comma minus 1 when we put that complex numbers in the complex plane. And then we get R is equals to square root of 5. Let's first try to draw the diagram for this one. Let's take the imaginary axis and let's take the real axis, and we'll try to take the center, which is 2 comma minus 1. And very clearly origin is passing through the circle, because if you find out distance between origin and this circle center here, we get is equals to radius, right? So that is why let's make sure the circle is passing through the origin. Okay, it's just a rough diagram, you need to understand it. So it will be centered somewhere here, 2 comma minus 1, right? And the radius is equals to square root of 5. Now let's go to the next part of the question. If the complex number z naught is such that 1 divided by modulus of z naught minus 1 is the maximum of the set 1 by mod z minus 1, where z belongs to capital S here. Okay. So if you look at that set here, set containing 1 divided by modulus of z minus 1 such that z belongs to capital S. Okay. So you need to understand the meaning of this set notation here. That is, that is, in this set here, it has the values of 1 divided by mod z minus 1, where z must be taken from the set S. But what is actually set S here? It is a region which is on or outside this circle, right? So z is a complex number which is lying on or outside this circle here. And you take the values of z from that set and you try to find out the values of 1 divided by modulus of z minus 1. And for all such values, this 1 by modulus of z naught minus 1 is representing the maximum value as per the question here. So which means z naught is a value uh, which satisfies the condition here, which is the maximum point. But we know very well, right? If this modulus of 1 by mod z minus 1 is to be maximum, the denominator mod z minus 1 is to be minimum. And that's a simple logic. It's in the denominator, right? So if 1 by mod z minus 1 is maximum, we just need to ensure mod of z minus 1 is minimum here. But what exactly is the meaning of mod z minus 1? It is simply representing the distance between the complex number z and the complex number 1. And what is the reason behind that? We know that whenever we have mod of z1 minus z2, it represents the distance between the 2 points z1 and z2. So clearly here mod of z minus 1 represents the distance between the complex numbers z and 1. So here, since you have to minimize the value of mod z minus 1, we just need to minimize the distance between the two complex numbers z and also 1. Okay. Now let's try to understand what is this one complex number here. That's nothing but the coordinate 1 comma 0, right? So let's put that in the diagram as well. Let's put that 1 comma 0 in the diagram. So which will be somewhere here, 1 comma 0. Okay. Now let's try to analyze the diagram here. Now the question is completely based on diagram. Z is a point which is moving on or outside the circle, whereas 1 comma 0 is a fixed point on the real axis here. Now we need to make sure that distance between that variable complex number z, which is on or outside the circle, and the complex number 1 comma 0 is minimum. But from the concepts of circles, what do we know? If there is a point somewhere here like this in this question inside the circle, and if we have to minimize the distance of that point from a point which is lying on or outside the circle, it has to be along the normal drawn to the circle through the point 1 comma 0. Okay, because the shortest distance always occurs along the common normal, right? So let's take the normal, and very clearly this is the point which is to be taken, that is z naught. so that the distance between that z naught and 1, that is z and 1, will be the minimum because it always occurs along the normal. Okay. So you might think it might also occur on the right side also, but from the diagram it is very clear that only if you take that z naught at the top of the circle, it will be minimum. Okay. So that is your point z naught here. Now, the question is not done yet. The only thing we need to understand here is Z naught is a point which will be lying somewhere here. Okay. And actually, we don't need to find out the value of Z naught here for this question. You might think we have to find out the straight line equation and solve it with the circle to find out the Z naught. That is not required for this question. I'll tell you why. First of all, Z naught is a complex number, right? So let me take that Z naught as x plus iy. But from the diagram, it is very clear that the x coordinate of the point, look at that diagram, the x coordinate of this point Z naught is a value lying in between 0 to 1 because it is on the left side of 1 comma 0 and the right side of origin. That is why, let's write down that here itself. The x coordinate. X should be lying between 0 and 1. And what about the y coordinate? We can say here, obviously, it is greater than 0 because it is above x axis, right? So we have the two conditions. So let's keep that in mind. Now, since we have taken z naught is equals to x plus iy, now let's look at the required part here. The required part is argument of. So let us write down argument of what? 4 minus z naught minus z naught bar whole divided by z naught minus z naught bar plus 2y. Now let's put the values of z naught here in terms of x and y. 4 minus x plus iy minus of z naught bar is nothing but x minus iy whole divided by, again, z naught is x plus iy and minus of z naught bar is x minus iy plus 2y. So you can simplify the numerator part, right? So clearly plus iy minus iy gets cancelled. Remaining part will be 4 minus 2x. And what about the denominator here? It will be 2y and then x will be cancelled out plus 2iy will be remaining. And moreover, you can cancel out the common factor 2 also. So from which you will be getting 2 minus x divided by y plus 1 multiplied by I. Okay, so this is the remaining part. And since we have plus I in the denominator part, we can multiply and divide by I so that that complex number I remains on the numerator. So if you do that, finally what we get is this value 4 minus z naught bar whole divided by z naught minus z naught bar plus 2y is equals to the denominator I into y, I square, which is minus 1. So if you take that minus the 1 here, and it will be minus I multiplied by 2 minus x divided by y plus 1. Okay. So this is the complex number which they are asking about. But the question is what? We have to find out the argument of this complex number. Now, the reason why I told that finding z naught is not important here is the simple reason because here x and y are real numbers because when you take a complex number as x plus iy, x comma y must be real numbers here. So this 2 minus x divided by y plus 1 is a real number. And more importantly, here x belongs to 0 to 1 and also y is greater than 0 here. So which makes this 2 minus x as positive. I'll mention that condition if you want. X belongs to 0 to 1 and y greater than 0. So if x belongs to 0 to 1 and also y greater than 0, this value here will be a real number and also a positive value. Okay, that's the main advantage. So I'm going to write this as some minus I multiplied by k, where I'm assuming that k is equals to 2 minus x divided by y plus 1. So clearly we can notice that k is always positive here. So for this complex number, we have to find out argument. So let's take the argument of this complex number. What do we get from here? Argument of minus I times of k is equals to argument of minus I plus argument of k. But anyhow, k is a positive real number. In the last question also I told you, whenever we have argument of positive real number, it is always 0, right? We can take it as 0. Remaining part is only argument of minus 1 and minus I, I'm sorry. So what is argument of minus I minus pi by 2? So which means the argument of the required Complex number is simply minus pi by 2. And I hope now you understood why I did not even try to find out the value of z naught here. Okay, because it's not even required. We just need the range of x and range of y to conclude about the argument of this complex number. Okay, so this is the interesting part, but it's a pure geometrical application question, right? So it's very important. Let's take the last question for this video, and this is one of the interesting question asked from JEE Advanced 2018 from chapter complex numbers. It's very interesting question, a pure geometrical application, and it's a very good question also because a lot of calculations are involved once again. But let's try to understand and take the concept from here. Let's read the question first. Let S comma T comma R be the non-zero complex numbers and L be the set of solutions Z is equals to X plus IY, where X comma Y belongs to capital and I is equals to square root of minus 2 of the equation. Now we have to concentrate on this equation here. S into Z plus T into Z bar plus r is equals to 0. Okay. Now we have to concentrate more on this equation only because only if you understand this equation, you can check the options here. So let's read the question. What is the given part? Which of the following statements is are true? So clearly each and every question is each and every option here is based on the set L here because L is representing the solutions of this equation. Now this equation has a lot of importance here. And moreover, you need to understand that S comma T comma R are non-zero complex numbers, right? So I'll tell you what is the exact conclusion should be drawn from this equation here in a brief way. So if I try to put S is equal to some complex number, some S1 plus I into S2, and obviously Z you will take it as X plus IY, and you will take T as what? T plus I, T1 plus I into T2. And similarly, we know what is Z bar, that is Z is equals to X minus IY, and again R is nothing but some R1 plus I into R2. Right? So if you substitute all these and if you try to separate the real and also imaginary parts, okay, if you try to separate real and imaginary parts here, so very clearly you can notice that you're going to get two straight line equations. Okay. So I'm not doing the calculation part. I'm leaving that calculation part to you because it is a derivation of this property. So the first real part here is going to be a straight line. Okay, let's take it as some straight line L1. And the imaginary part here also will be of the form some straight line. Let's take it as L2. Okay, and if we equate the real and imaginary parts to 0, we get L1 is equals to 0 and L2 is equals to 0. So whenever we have two straight lines in a plane, clearly only three conclusions are possible, right? Because when you have a combination of two straight lines, there are only three possibilities. Either they are non-parallel and which will meet at only one point, and it can be two parallel lines but not coincident. So in this case, no solution will be there. In the case one, in this diagram, you can notice non-parallel case, only one point of intersection. That is one solution. Otherwise, the two straight lines can be coincident lines. So in this case, you have infinite number of solutions. And you are taking the intersection of these two lines because both L1 should be is equal to 0 and L2 is equals to 0. So it's like solving two simultaneous straight lines. Okay. Now let's write down the conclusion. So as I told, this is all the derivation part. Now let's write down the conclusion very clearly here. It's very important. When I have the complex equation S into Z plus T into Z bar plus R is equals to 0. So this will give you one of the three conclusions here, that either this will have no solution in the case of parallel but not coincident, or only one solution like in the case of non-parallel case, and then infinite solutions. Infinite solutions like the coincident case. Okay, let's keep this in mind. Now let's start the solving process of this question. Okay, so the idea here is writing S into Z bar plus T into S into Z plus T into Z bar plus R is equals to 0. Let me take it as some equation number 1. And I will take the conjugate to the entire equation and take it as equation number 2. I will take the conjugate on both sides of this equation, and from which I'll be getting S bar into Z bar plus T bar into Z bar whole bar will be Z plus R bar is equals to 0. Okay. Now the reason we are doing whole conjugate on both sides is we are trying to separate the value of Z from here. So obviously you can solve this part, right? So you know how to solve this one. You will take the value of Z bar from this second equation and take it and substitute in the equation number 1 to completely separate the value of Z. So once again, I'm leaving the solving part for you. It's not a difficult thing, just solving two equations in two values, Z and Z bar. So take the value of Z bar from here and substitute in the equation number 1, and you properly try to separate the value of Z. Okay. So as I told, I'm leaving the calculation part for you guys. So if you do that, you will get Z, an equation something like this, that is mod S square minus mod T square multiplied by Z is equals to R bar into T minus of R into S bar. You will be getting something like this. Okay, now, and we are getting in terms of mod S and mod T because while solving, you will be coming across these things, S into S bar. But we know that S into S bar is nothing but what? Mod S whole square. Similarly, you are seeing this mod T whole square because while solving it, you will come across T into T bar, which you'll replace it as mod T whole square. Okay. Now, let's start the conclusions from options here. Look at the option 1. If L has exactly one element, then mod S not is equals to mod T here. Okay. So from this equation also directly you can tell the result here. Okay. That is, if let's take the first option here. What is it? L has exactly one element, then mod S is not is equals to mod T. So very clearly, if mod S is not is equals to mod T, clearly mod S whole square is also not is equals to mod T whole square. So from that, you can write down Z is equals to what? R bar into T minus R into Z bar whole divided by mod S whole square minus mod T whole square, just because you know that the denominator is not 0 here. Now clearly, for a given complex numbers R, S and T, this value is going to be a fixed value. For a given values of R, S and T, this is going to be a fixed value. Okay. So if it is a fixed value, which means you get only one solution, right? Because if R and S and T are fixed, obviously this will be a fixed value. So which means you get only one unique value of Z in the case of mod S is not as equals to mod T. Okay. So which means option A will be true here. Okay. Now let's take the option 2 here. If mod S is equals to mod T, then L has infinite many elements. Okay. Now let's come back to this equation here. If I take the second option, mod S is equals to mod T, let's put that here. Left hand side will be 0 times of Z is equals to R bar into T minus R into S bar. So clearly left hand side is always 0. So 0 into Z is equals to R bar into T minus R into S bar. Okay. Now in this case, they are saying that this L has infinitely many elements. Okay. But it might not be correct, right? Because here, since left hand side is 0, right hand side should also be is equals to 0. But obviously different cases are possible. So this right hand side value, if it is so if this right hand side R bar into T minus R into S bar is equals to 0, then we get an equation something like this, right? 0 into Z is equals to 0. So which means in this case Z can be any number, right? Because left hand side any value of Z if you put, definitely 0 is equals to 0 you're going to get. So in this case you can get infinite number of solutions. But what happens if R bar into T minus R into S bar is not is equals to 0? You get something like this, right? 0 into Z is equals to a value which is not is equals to 0. A value which is not is equal to 0. So left hand side is 0, right hand side is non-zero, which means it is not possible, right? So that is why in this case, if mod S is equals to mod P, different cases are possible. Either it will have infinite solutions or it will have no solution as I have written here. Okay. But in the option C, option B, they are saying that it will have infinite number of elements. So which means it is not correct because other case is also possible. Now the third option here. So for the third option, we need this concept of no solution, one solution, infinite solutions. Look at this. It is the intersection, number of elements in the intersection of L, and this is modulus of Z minus of 1 minus I is equals to 5. I'm rewriting that modulus value as modulus of Z minus of 1 minus I is equals to 5. But what do we know here? When we have modulus of Z minus 1 minus I is equals to 5, center will be 1 minus I and radius is equals to 5. But moreover, it is a circle. Okay? So it is a circle. Now, what exactly you are trying to do? You are taking the intersection of this circle and the set L here. But what is set L representing? Either one single solution or no solution or infinite number of solutions, that is two coincident lines. Okay. Now, if you observe carefully, if you take the common part of these two, the maximum number of elements possible is only two. Okay, because when you take a straight line and a circle, the maximum number of points of intersections is only two, right? That is why here only maximum two solutions are possible, because in case one, no solution, it is not possible. And in case two, it is going to represent one single solution, that is only the point of intersection of those two lines. And in that case, you can get maximum of only one solution. And if you take infinite solution, which is representing this one single straight line here, so if that line is meeting this circle like this, so obviously it will have 2 points of intersection. That is why maximum two solutions are possible. So which means option C is correct here. And look at this option D. If L has more than one element, then L has infinitely many elements. That's also obviously correct, because if you look at the set L here, either it has no solution or one single solution or infinite number of solutions. So if you read that option D, if L has more than one element, then L will have infinite number of elements. That's the thing we are concluding from the third case here. That is, it will have infinite solutions if the top two cases are not possible. That is why option D is also correct. Okay. So as I told, this question is not definitely easy. Lot of calculations are required, and also the concepts of circles, straight lines, and also this interpreting this equation is also there. Okay, so it's very important model. So these are the 5 questions from complex number from JEE Advanced. Now I will take the remaining questions in the next part.